OSPF has so many concepts to it. It's amazing. And that list is about to grow right now as we get into the router LSA types and summarization options. We'll start things off by doing a little review of the OSPF areas and why we have areas and the router types that exist in OSPF, because knowing those router types are going to be essential when we talk about summarization. That's the second thing. Summarization in OSPF. How do we do it? Depending on what kind of router we're on, our options differ. Finally, we're going to take a look at the different types of LSAs. And if you remember back to the concepts, that stands for Link State Advertisement. It's one of the most foundation packets to OSPF, but you're going to find out after this video, it's not just a packet. There's many LSA types that exist, each one doing something slightly different. So let's get going. I want to start off by doing a little bit of review. Early on in OSPF, we talked about this concept of areas. And everything always started in area 0. When we initially configure routers, they all go into area 0. That is considered the backbone. And as our network grows and we add more areas, they have to be united directly to area 0, the backbone area. And that's what you can see with area 2 and area 1, our regular areas up here, that are linked into the backbone. But with that foundation, why did we divide into multiple areas? Well, it was for efficiency. As the routing table gets bigger and bigger and the topology database gets bigger and bigger, things become less efficient. Packets take longer to forward because the router has to figure out in the routing table what the best match is. Anytime a network change occurs, updates go throughout the whole area because, remember, every router in the area has the same topology database. So they know about every change that's happening within the area. So if you wanted to hide those changes, meaning you want to keep those changes from flooding all the routers, that's where the multiple areas can come in. It makes the topology database smaller. It makes the SPF algorithm more efficient. Every time it runs to recalculate the routing table, the size of that topology database determines how long it takes that algorithm to run and how much processor cycles it's going to cost. So that was why we divided up into multiple areas. It was just for efficiency's sake. Now with that, I also want to make sure I hit the router types. Now, I don't think I discussed these early on in the concepts, but I mean, it's pretty straightforward. Internal routers and backbone routers. Internal routers are routers that are completely within an area. Now, this is a very logical diagram, as in it's not physically representing all the routers. In router 2, there's probably some routers that are all sitting in there, and those are all internal routers, meaning they are completely immersed in that area. This is an internal router because it is completely immersed in the backbone. It doesn't have any other interfaces in other areas, but it is also considered a backbone router because it is in area 0. It has at least one interface there. This is a backbone router as well as this. Any router that has an interface in area 0 is considered a backbone router. Now, the routers that have one leg in more than one areas is considered an area border router. So it could be in 2 areas, it could be in 3 areas. We had another interface over here. It could be in 5, 6, however many interfaces you want, and however many areas you're linked to. However, typically they'll link up 2 areas. Down here we have an autonomous system boundary router, one that allows you to get outside of the OSPF domain. This could go to the internet. It could go to a RIP network, to another OSPF network that's not under your control, to a BGP network. It's any other routing protocol other than OSPF that is under your control is linked up through the ASBR. It has 1 foot in OSPF and 1 foot or more in other routing domains. Now let's move into how to do summarization in OSPF. You can see the same basic network setup on the screen. Backbone in the middle, RIP domain on the right, area 1 on the left. Router 2 is acting as the area border router. Router 4 is acting as the autonomous system boundary router. Depending on which router you're on, the summarization commands will look different, so it's essential to know those 2 roles. Now, I've set up OSPF already on router 1, 3, and 4. They're already running OSPF, and of course, these are running RIP down here. I've saved router 2 to set up from scratch just because I want you to see how easy it is to configure an ABR. Bring up router 2 right now. and go into, I'll just do a show IP protocol, make sure, yep, no protocols running. Go into global config mode. And I'm going to type in router OSPF1, start the process. First thing I'll do is set the router ID. I like setting the name of the router to the host name. So if it's router 2, I like all 2s. And now I'll type in my network commands. IP addresses would have been handy. Let me jump back and do a show IP interface brief. And I can tell you that serial 1.1 is connected to router 1, and 1.3 goes to router 3. So this is area 1 and area 0. I did that on purpose. I get into router OSPF. I'll type in network 10.1.12.2, 0.0.0.0, area 1. Enter. Network 10.1.23.1, 0.0.0.0.0, area 0. Enter. Just like that, an ABR is born. There's nothing more to it. Just by putting one interface in each area, this is now known as an ABR to the OSPF routing process. You can see the neighbor on each area formed. So router 1 in area 1, router 3 in area 0 has formed. So I now have, or should have, OSPF routes coming into the routing table. Type in show IP route, and sure enough, there's all my 192.168 routes. They're all originating over here from area 1. So those are being received by router 2. And it looks like it's got one route coming in from the area 0 router, which is advertising this WAN link over on that side. So router 2 is now effectively an ABR. Type in show IP OSPF and just hit enter on that just to verify. And you can see that we have an interface in area backbone. You can see number of interfaces, 1. So we have an interface that is in area 0, and we have an interface in area 1. That is a quick way, anytime you're doing a show command, to tell that this router is an ABR. Now, the summarization command is a little funny. It's a little tricky. It's first off done from the routing process. I wish it was like EIGRP and put underneath the interface that you want to send it out of, but that's not how it works. We go under the router process and we type in the area that we would like to summarize. So in this case, I did the show IP route up here, and I saw I'm getting all these 192.168, 4, 5, 1, 2, 3 routes coming from area 1. And I don't want to send all those to area 0. I just want to, sum them up. Just send one big advertisement. So router 3 just has one advertisement that affects the entire area 1. So what I'll do is I'll say the area that I want to summarize is 1. So I'm going to type in area 1. Question mark after that. Now it says, do you want to set up authentication for the area? Do you want to set up a default cost that's used with redistribution? There's a lot that you can do, but the main thing I want to focus on for now, we'll go through a lot of these other commands later, is the range command. The range command, it says area 1's range is represented by, and I hit the question mark, and I have my summary address that I can type in. I'll be lazy in this case and just put 192.168.0.0. Now, it's going to ask me for the mask, which I'll follow that up with. It's a subnet mask, not a wildcard mask. But as soon as I hit the enter key, something amazing happens. OSPF automatically suppresses any routes from area 1 that match the summary address that I've typed in right here. So all of the advertisements that I'm receiving from area 1, the 192.168.1, 2, they're going to be suppressed by router 2, and only this route will be advertised to other areas. So the reason I say the summary command is a little finicky is I've seen a lot of mistakes made when I'll confess, I've made a lot of mistakes when I've gone into a router and said, oh, I want to send the summary route to area 0. So I type in the area 0 range, but this really reflects what routes you want to summarize from area 1. You're typing in the area you want to summarize. So I hit enter on that. Now, as soon as I do that, I'll hit Control Z and do a show IP route. You can see that I have all of those routes still in the routing table, but look at this. I have a new route that has come in. It says 192.168.0.0/16 is a summary, and it points to null 0. Whoo! What's null 0? The Garbage can. That means anything that matches this route gets thrown away. Now, initially that's not good. All of those networks have become unreachable, right? Well, remember the way that a router matches routes. The number one thing that makes the route selected is how specific the subnet mask is, the specificity of the route. You can see right here, all of these have specific /24 subnet masks. So if a packet is destined to one of these routes, the router's going to say, I got it, and I'm sending it out to this neighbor out serial 1.1. The only time it will match this route is if it's to 192.168.6. Something or 7. Something or any of those routes that are not reflected here in the routing table. This is a loop prevention mechanism to keep the router from suddenly going into query mode, like I need to find a backup route or something to a network that never existed in the first place. So that's what that null zero route is in the routing table. I'm going to do a show IP OSPF database, and I can see, sure enough, that I've got my summary route that is in my database, and that's being advertised to area 0. Let's hop over to router, that would be router 3 to see the effects. Jump over here, router 3, just do a show IP route. Hit enter, and sure enough, looks good. I've got an inter-area route. That's what the IA stands for. And you can see that it's only receiving the summary route 192.168.0.0/16. There's its administrative distance. There's the cost of that route, next hop address. The only other route that's coming out of the area is just the inter-area link. That's the WAN link between router 2 and router 1 in area 1. We didn't have that as part of the mask. So it's that easy to create the summary routes on the ABR. There is one thing I wanted to show you. I forgot to do it. I'm going to do that area 1 range command and just follow it up with a question mark, because this will throw some of you off if you're used to using the question mark. It comes up and says, oh, do you want to advertise this? And a lot of people type it in just to be safe. But remember, that is the default. As soon as you type that in, the specific routes are suppressed. This one is advertised. Also notice that it says not advertised, which means I can put in a summary route, but not advertise it. Now, you might be wondering, why on earth would I do that? And my point is, it's a good question. Not many people do. The only reason I could think that you would do that is if you wanted to suppress some of those routes from being heard about in other areas. Because as soon as you type this command in, whether you advertise it or not, it's going to suppress those routes. So by putting not advertise on there, you're suppressing them, but not advertising the summary route, which means on router 3, its routing table would just not even show that. It would not show that whole range from area 1, and you've effectively hidden them from the rest of the network. You can also specify another cost if you want to do that for that route. But again, that is how we set up the summary routes on the ABRs. Now let's focus on the ASBRs. Router 4 is our ASBR, so we'll hop on over to there. Let's just clear off the screen here, get rid of all that distracting stuff. I'm going to type in a show IP route on router 4. And we can see that, yep, sure enough, it is a RIP router. I'm getting all kinds of RIP routes. 172.16 routes, it looks like. Yep, matches the diagram, /24. So it looks like router 5 is sending a bunch of RIP routes to router 4, which as of right now is running OSPF. You can see it's receiving the inter-area routes just as well. So it's running OSPF, but it's not advertising these because they're not OSPF routes. It doesn't automatically just pass those into OSPF. We have to send them in, and that's done through redistribution. Now, on an ASBR, I'm not going to get into the redistribution here. On an ASBR, the command to do a summary route is a little bit different. We're going to go into router OSPF 1. The command is actually summary address. Now, the summary address command has no area behind it. And the reason why is because this is not an area. It's a RIB domain. Area is terminology that's specific to link state routing protocols, which RIP is not. So it makes sense that the summary address command, which is used on ASBRs, wouldn't have an area because it's not summarizing other areas. It's summarizing other networks. We'll do 172.16.0.0, followed up with a question mark. Summary mask 255.255.0.0. Again, this is not good summarization. It's lazy summarization. It's just example summarization. That's what we'll call it. So I've typed in my summary address, and now it comes up and says, do you want to advertise, not advertise? Advertise is the default. Or do you want to tag this route? Tags are awesome, but we'll get into that when we get into redistribution and some of the advanced routing methods that we have available to us. But for now, I'm just going to hit enter to advertise that summary address. Now, I'm going to jump over to router 3 and let's see if this is being received. Remember, router 3 is the one right in the middle here between router 4 and router 2. So I'm going to do a show IP route, and no. Let's do a show IP OSPF database and see if we even get it in the database. No. The reason why router 3 is not getting that route is because router 4 is not sending anything into OSPF that has 172.16 with it. Just like the area range command that we typed in on the ABR over here, router 2 has to have some routes to suppress in the first place before it will advertise those summary routes. If we would have typed in area 1 range and done that same command, but area 1 didn't have any 192.168 routes, well, then router 2 wouldn't advertise the summary routes because it's going to say, I don't have anything to summarize. And in the same sense, router 4 in its OSPF world does not have anything to summarize that starts with 172.16. It does in the RIP side, but we haven't sent the RIP routes into OSPF. So what I'm going to do is jump on over to router 4. It's router 4, right? Yep, one more time. And I'm going to step into something we're going to talk a lot more in the future videos on routing protocols, and that's redistribution. I'm just going to do the simple redistribute command. Type in redistribute RIP, period. That automatically sends the RIP networks into OSPF. Ooh, and I forgot. You can see the little note. Only classful networks will be redistributed. That's because I didn't follow it up with the keyword subnets. By default, OSPF will summarize back to the classful network when you do redistribution from other domains. I don't want to summarize because I manually worked to put a summary route in there, and I want that summary route to take effect by golly. So I'm going to make sure I type in redistribute routes subnets, which says I want to send all the classless networks in there. Now when I jump over to router 3, the one in the middle, and do a show IP route, I now see the 172.16.0.0 route. Look what kind of route it is, though. It is an external route to OSPF, an external type 2 to be more specific. Again, we're talking about some things we're going to talk about later on when we get into redistribution, but that is a summary route. That's where the summary address command has taken effect to wrap up those 172 networks into just the 172.16.0.0. And I know we didn't do this before, so let me do this. I'm going to go to router 4, and I'm just going to hit the up arrow and do the no summary address to remove that summary route. And when we go back over to router 3, I know I'm jumping pretty fast here, but there it is. You can see as we remove the summary address, all the more specific routes come through, thus making our routing table more difficult to deal with. So that is the two ways of doing summarization. One more time, router 2 is an ABR, uses the area range command. That's what happens when you talk and type. Area range. Router 4 is an ASBR, uses the summary address command. So depending on which one you are, different commands take effect. Now let's shift over to one more big topic for this video, and that is LSAs. Now you may remember from back in the concepts, we talked about the LSUs, the link state updates, the LSA, the link state advertisements. These are all the pieces that make OSPF works. The LSAs were the individual advertisements about specific networks. The LSU was kind of like the coupon mailer, the packet type that gets them there. This is where you find out there are many types of LSAs that exist in OSPF. And I define them as the building blocks of OSPF. They help build that topology table. And many types exist. Now, I have 5 of them on the screen. These are the 5 number 1 most common LSA types that exist in OSPF, but there are actually 11 of them out there. We're only going to talk about, well, 6 of them as we go throughout here. And when we get into some of the other area types, we'll discuss the 6th. But we're only going to primarily focus on these 5 because they are the core of what makes OSPF works. The other ones are kind of extensions. They work with IP version 6. And again, we'll talk about those a little bit later. So LSA types, what I wanted to do was first off show you a packet sniff in Ethereal. Now, in days of old, I used to hate packet sniffing. When I got into Cisco, I loved it because it really shows how things are working. Let me just kind of scooch this up to fit the screen size. Now you can see I've been sniffing and I captured a bunch of OSPF hello packets. You can see my 2 neighbors that I captured it from, 10.50.10.1 and 10.50.10.5. So I went down and hello, 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 hello. They were sending hellos. And eventually they started exchanging some updates. Now right here is where the LSU packets begin, link state updates. And you can see even Ethereal recognizes it as an LSU. Inside of here, you can see the frame. This is layer 2, this is layer 3 information, the IP layer. And then we have layer 4, open shortest path first. And then right inside of that, as we expand it, has the link state update packet. Expand that out, and you can see inside of the link state update, isn't that coupon mailer just such a good picture now? You can see this is just a container. Inside of it contains 1 or more LSAs. In this case, we just had 1. In that LSA, you can see, is a router LSA. I expand that out, and you can see that this was a link advertisement from this router, and we could expand it out even more to find out it was an advertisement about 10.50.10.0 with this subnet mask, metric of 10. That's the type of advertisement that it was. And you can really get nitty gritty with these packet sniffers to find out what was inside of there. But look at this. We click on this, and they stayed expanded out. There's another one that was advertised between them. Expand it down. Now here's one coming from router 3, 3.3.3.3, another mention that was being sent. But I want you to see these are all router LSAs. And then I come, oh, look at this, link state update, an update, and then this one is a network LSA. Look at this, router LSA, router LSA, router LSA, network LSA. So we have all of these different LSA types that are out there, and that takes us back to the slide. The most common type of LSA that you'll experience is a router LSA. A router LSA is an advertisement about one network, meaning, hey, this is the 10.10.10 network. I just wanted you to know about it. This is how far it is away from me. These are your normal routing updates that you would expect to see, and what most people understand as a routing update. Now, the LSA type 2 is only generated by a DR. I purposely did that capture on a LAN segment because I wanted one of the routers to be elected as a DR and to send a type 2 LSA. The type 2 LSA is a network LSA which just advertises all of the routers that are plugged in to the same Ethernet segment. It wants to let all the other routers know, hey, all of these neighbors that you have in the database, yeah, they're all plugged into the same switch. They're all connected to the same Ethernet segment because that helps the router make more intelligent decisions about which path to take. It also helps them to get a view of what the topology looks like. And you look back here at Ethereal, and you can see that the network LSA, sure enough, you look inside and you can just see attached router, 3.3.3.3, attached router, 1.1.1.1. It's just an advertisement. It doesn't actually advertise a network. It's an advertisement that's advertising 2 routers that are plugged into the same Ethernet switch. Type 3 LSAs are summary LSAs. When we were doing the summarization on the previous slide, when we set it up on the ABR, it changed the advertisements to type 3 LSAs. I wish I could have grabbed Ethereal to do that. However, I couldn't sniff the WAN link. And I figured by the time I set up redirections and so on, it would just be a lost cause. So type 3 LSAs are summary LSAs that are the summarized routes. Now, there is something I want to make sure you know, and that is, let me bring this back up into the window. When you have an ABR right here, whether you're summarizing or not, type 3 LSAs are coming. So, for example, when router 2 talks to router 3, if it's advertising, let's say, this network in area 0, then that is going to be a type 1 LSA, just a normal update. But if it's advertising anything from this other area, that is going to be a type 3 LSA that comes over to router 3 and is received. Now, that type 3 LSA gets sent whether or not you are doing summarization. Just the fact that it is in another area is a type 3 LSA. And as I'm saying this, I'm just thinking to myself, why is this important? I want to make sure I define the why before we continue on this list of LSAs, because somewhere around 4 or 5, you're going to be like, I don't need to know this. Oh, you do. You do. These LSA types are critical because in the upcoming nugget, either the next one or the one after, I haven't looked at my spreadsheet yet, but we're going to talk about the different area types. So far, we've seen the backbone area and normal areas, meaning just regular, areas that are out there. But there are actually many different types of areas that you can configure beyond those two. And depending on the type of area you set up, the router will block certain LSA types from entering the area. So by knowing the LSA types, you really will know what the router is blocking. So type 3 LSAs represent summaries that come from ABRs. Type 4 LSAs is also considered a summary. And when I say considered summary, that means like if you were to pull up Ethereal and look at it right here, it would say LS type summary LSA. That's the name where it comes from. This is actually known as the ASBR location LSA. It's one of the weirdest LSAs in the book, in my opinion. What it is just the IP address of the ASBR in the network. That's it. Not its summary routes, not what routes is it originating, just its IP address. The reason that that's good and the reason that we have LSA type 4 is because there may be times where, let me bring this back up, there may be times where this guy's advertising routes, and there's ways to keep router 3, router 2, and all that from changing the next hop IP address. So maybe router 4 remains the next hop IP address for all the external routes. Well, by knowing router 4's IP address, that IP address on its interface right there, all the other routers in the domain will say, oh, okay, well, I know how to get to these external routes because I know how to get to router 4. That's what the type, I'm just flipping slides all over the place. That's what the type 4 LSA does for us, is it advertises the location of the ASBR. Type 5 LSAs, that's the one that advertises the ASBR's routes. So any route that I send in from an ASBR, oops, I'm just lost in my slides, forgive me. Any routes that I send in from router 4 right here will be considered type 5 LSAs. Again, if I were to grab those with a packet sniffer, I would see external LSA in the ethereal output on there. So just about every single one of those 5 types of LSAs you will see in an average production network. As we wrap up, I just wanted to give you a visual representation of where these LSAs fit in. You can see that I have area 1, 0, and the RIP domain over here on the right-hand side as we worked with this whole video. And I have the 5 different LSA types that come into play on the left-hand side. Now, over here in area 1 is where I want to begin. Let's imagine that this router has the 192.168.1 network down here, 1.0. It's going to advertise that network to this router using, well, you tell me, what LSA type do you think from this list? Yeah, you got it. I hope. It was LSA 1. So this comes across as LSA type 1 to the ABR. But this ABR right here, as soon as it receives it, will convert it as it sends it to area 0, no matter if I'm doing summarization or not, to an LSA type 3, because now it has become a summary route or a route from another area. So these routers all receive that as an LSA type 3. Now, this Ethernet segment right here, they all have their own networks. They're all sending their type 1 LSAs to each other. But the DR, whoever is elected as the DR, will send an LSA type 2 out to the network. And that goes to every single router that is attached to area 0. So this router gets it, every router gets it, and all that LSA type 2 is telling is all of the routers that are plugged into this same Ethernet switch. So all three of these routers will be listed in that LSA type. LSA type 4 is the IP address of the ASBR, which is this guy. So this OSPF IP address will be advertised to everybody in the whole OSPF network. No matter where they are, they will know that person exists. This ASBR exists, and this is their IP address. Any of these RIP routes that are advertised into the network will come in as LSA type 5s. Those are the summary routes for the external system. So all the routers will receive those in all areas, depending on the area type. Again, we haven't gotten into the different types of areas yet, but they will all be seen as LSA type 5s. Okay, let's tie things up there. A lot of good concepts in this video that we're going to be using in future videos for OSPF extensively. First thing that we talked about was OSPF areas and router types. Primarily a review because you need to know why we have multiple areas, of course, but also what types of routers there are, because depending on the type of router you're on, depends on what command you'll use for summarization. That was the second thing we talked about. On an area border router, you use the area range command, whereas on an autonomous system boundary router, you use the summary address command. Finally, we moved into the OSPF LSA types, the link state advertisements, the building blocks of the OSPF database. And we looked at the 5 different types of LSAs that we use primarily in the OSPF process and what they did. Because as we get into the areas in these upcoming videos, you're going to see some LSA types are not accepted in certain types of areas. I hope this has been informative for you, and I'd like to thank you for viewing.